Hello everybody, this is ADVM 12, Unit 3 lecture for General Dimensioning Requirements by Todd Frazee. Introduction. This lesson on general dimensioning requirements will provide you with the foundational skills needed to apply proper dimensioning techniques using the correct line types, lettering sizes, arrowhead forms. You will learn how to strategically place dimensions and tolerances on annotated planes and models, ensuring clarity and accuracy. Additionally, we will explore the best practices for dimensioning to achieve the desired fit and function of parts, as well as the preferred methods of specifying part requirements. The lesson will also cover the application of general and specific notes on a drawing and introduce the different types of fit between mating parts. By mastering these concepts, you will be equipped to create precise and professional technical drawings that meet industry standards. Objectives. The objectives of this course. By the end of this lesson, you will be able to apply general dimensioning methods using the correct line types, letter sizes, and arrowhead forms. Understand the placement of dimensions and tolerances on annotation planes and models. Apply dimensions using the best methods to achieve the desired fit and function. Utilize preferred dimension placement to provide clear and part requirement specifications. And apply general and specific notes on a drawing. And finally, to cite the general types of fit between mating parts. Applied dimensions. Undimensioned models rely on model and supplementary geometry to establish dimension values. Saved views are part of the product definition data file and may exist without multi-view drawings. A query method, a model means to interrogate or inspect one or more model features to determine the attributes from the model. Resolve value is a queried value rounded off to the predefined number of decimal places by the software. Annotation planes and models. Conceptual and used for placement of notes, dimensions, and tolerances. They ensure lines, arrowheads, dimension values, and directly applied tolerances for each dimension all lie in a common plane. Annotation plane placements must be coincident or parallel to a feature plane or of a feature, or coincident with a parallel to center plane for a feature of size, or coincident with an axis of a feature, or perpendicular to the feature or its axis, usually parallel to planes created by the coordinate system axes of the model, but not required when the feature is inclined or skewed, which is an exception. Dimensioning methods. ASME national standards ensure consistency and clarity. Compliance necessarily so information exchange is successful throughout the United States and internationally. It includes product documentation, note invoking applicable standards. Be aware of the ISO standards or company-specific standards that are going to vary from ASME standards. Location and size dimensions. Dimensions show size, distance, angle, or location. Location dimensions indicate where one feature belongs relative to another. Size dimensions define how large a feature is. Dimensions must not be established in all three axes. Lines for dimensioning. Extension lines extend features. Dimension lines show the direction and magnitude of a dimension. And the minimum recommended spacing between dimension lines is that the first should be 0.4 inches or 400 thousandths, or if you're in metric, 10 millimeters away from the edges of the part. And each subsequent line needs to be 0.24 or 240 thousandths or 6 millimeters away from the nearest dimension. Leader lines connect information to specific part features. So the leader line looks like an arrow with a note information to it, as shown on the left. Arrowheads and dots. So dimension lines are terminated with either an arrow or a dot. And for arrowheads used on a dimension and leader lines, it's acceptable to make the arrowhead length equal to the character height. Length to width ratio is 3:1. And it may be opened or filled. So that's allowed for the style. All four configurations you see on the left are acceptable. Dots are used to terminate a leader on a surface instead of an arrow. So you're denoting that you're pointing to a surface, and the dot needs to be a 0.062 or 62 thousandths or a 1.5 millimeter diameter filled circle. Character size and style. The number and letter height and style on the drawing must be the same throughout the drawing for dimensions. Dimension values centered on the dimension line and typically placed midway between extension lines. Other placements relative to extension line may be used. Align dimensions on annotated models. So an annotated model is a model that the dimensions can be shown, and again they have to be in common planes, and the dimension values must be parallel to dimension lines. An annotation plane containing dimensions rotates with the model to ensure the dimension application is unchanged. Now, unidirectional dimensions in annotated models only partially achieved on models. An annotation plane containing dimensions rotates with the model to ensure dimension application is unchanged. Align dimensions in orthographic views. No longer shown in ASME Y14.5. You'll see this in other industries related to architecture, but you no longer have vertical dimensions with the numbers going the same direction as the dimension line. The dimension values are in that style is parallel to the dimension lines. Horizontal values written left to right are read from the bottom of the page, and vertical dimensions are written from the bottom to the top and read from the right side of the page. So this is a practice that was used in the past that is no longer part of the standard. Unidirectional and orthographic views, and this is how it should be done now. All dimension values are horizontal and read from the bottom of the page, and used exclusively for ASME Y14.5 for orthographic views, and requires more space between vertical dimension lines because the text runs horizontally, so that standard of 0.24 between dimension lines doesn't necessarily apply for the vertical dimensions because you have to make sure that the numbers don't interfere. Scale. Models are always created at 1:1 scale, solid models. The scale for drawings is noted in a fractional form on the title block or in a ratio, and individual view scales noted below the view if it's different than what the sheet scale is. Do not measure features on a drawing to determine their size, and reproduced or printed drawings may not be exactly to scale because of imperfections in the process. So you always use the dimension values, not the size of the actual one-to-one print if it's a one-to-one. Okay, the measurement systems. U.S. customary system, basic unit of length is the inch. Used extensively in the United States, but almost nowhere else. The SI system is the basic unit of length is the millimeter. The unit length used on a drawing noted in our should be near the title block, and it's sometimes desirable to show both inch and metric values. So in prior versions of the standard, it was implied that the drawing was an inch. Now they're calling for a note to say one way or the other. Okay, inch dimension values must be shown as decimal inches, may be displayed as whole numbers in tenths, like 0.1, hundredths, 0.01, and thousandths, 0.001, or smaller if required. No preceding zero for the values less than 1. And the tolerance requirements may be affected by decimal places when the title block tolerance is used. Now on metric dimension values, the abbreviation of mm is not shown. Values less than 1 millimeter shown using decimals have a leading zero, so you can tell a metric drawing immediately if it has a zero before the decimal point. Whole numbers show no decimal point or trailing zeros. And accuracy may be affected by the decimal places if the title block tolerance are used, just like in the inch system. Okay, rounding dimension values. Do not change the last figure if the values following it is less than 5. Increase that last figure by 1 if the value is greater than 5. So you're going to round up if it's greater than 5. The last significant figure becomes even value if the value after is exactly 5. Rounding to 2 places for this example, 0.3125 becomes 0.31. 2.1261 becomes 2.13. Rounding to 3 places, 0.31250 becomes 0.312, and 0.43750 becomes 0.438 as we round it up. Okay, chain dimensioning. It's where you have dimensions that go from point to point. Dimensioning system where features are located from adjacent features. This will add up tolerance stack if you do this. It provides direct meaning of showing location requirements. Rectangular coordinate baseline dimensioning. Okay, is a system where features are located from a common line or point. Rectangular coordinate dimensioning without dimension lines. This used to be called ordinate, but the dimension shown on the drawing without using a dimension line, and it's used to indicate dimensions are basic. So you have to call an origin. In this case, it's the whole B is the origin. So anything to the left bottom quadrant is going to be a negative coordinate. Anything above the B, the whole B, is going to be positive coordinate in Y. And then traveling to the right, you have positive coordinates in X. This is a convenient way to dimension drawings that have a lot of holes, and you're programming them, and it allows you to program an incremental on a controller Don't see it so much anymore, but it is one way method that's still acceptable. So rectangular coordinate dimensioning using tabular dimensions tends to be in parts that have lots of holes and lots of different hole sizes and lots of locations. And it's not practical to throw dimensions between them. So you'll have a table that shows the location and sizes for large numbers of holes. The standard doesn't really force a standard format for that table as long as the pertinent information is available. And the hole identification symbol is shown in one column to identify the hole on the part. So an example, hole A1 is at coordinate x positive 1.5 inches, y positive 1 inch. It's an 1/8 inch diameter hole, and its tolerance is +5 -0. Okay, station points. They're used if a feature is a contoured surface and dimensional requirements are not defined by model geometry or mathematical data. Provides less dimensional control than model or mathematical data. And it's identified as reference information if the model or mathematical data define the surface. Okay, polar coordinate dimensioning. It includes an angular dimensioning component, and it's important for rotating parts. So you're going to have a distance and an angle. There's the direct combined dimensioning system. The combine use the best of all dimensioning systems. It allows the clearest communication of functional relationships and has directly applied dimensions to define feature size. So as you see on the left here, we've got a combination of different dimensioning systems. Okay, step block. This is a concept for when you're modeling parts to mentally break down it into parts into shapes that form it so that it's easier for you to visualize making the part. It ensures the part is completely dimensioned. So you mentally break it down into pieces and go, okay, I need to dimension the cylinders that make up holes. I've got a right angle. And it helps you keep track of what you've dimensioned. Okay, dimensioning feature contour. So dimensions applied where a contour feature is best shown. So you want to see the profile. So if you look at the dimensions on the left, in the front view, you've got the 1 inch and 3/8 because you're seeing the perimeter of those dimensions. Whereas the 1.5 that goes to an angled feature, it's better to put that one where it's following the profile of the top view. Okay, and it permits dimension and feature contour to be viewed simultaneously. Dimensioning between orthographic views. So this is where you have your dimensions in between two different views. Size and location dimensions placed between the views when practical. So rather than having them say all be on the top of each view, you want them in between the views if there's room. This is a style thing that's changed since I got into the industry. Do not place dimension between views if the extension lines run across several features within a part. So that'd be an exception. Dimensioning outside the geometry. Extension lines long enough so that dimensions appear off the part in any saved or orthographic views, and extension lines extend feature outside the object to allow placement of the dimension lines on the outside. So we have these extension lines, they come up to the part. Typically there's a little gap between it and the part, so you're differentiating it from the part, but it'll align from edges.